Looking at Chapter 6 on the sample exam, you may want to pause the clip before each question and attempt it on your own, and then I will do the solution. For number 28, which is a decreasing exponential function. And if you remember, an exponential function is of the form y equals a b to the power of x, where a is the y-intercept, or the initial value, and b is, if b is greater than 1, then it's an increasing function. If b is less than 1, greater than 0, of course, then it will be a decreasing function. So if we look at a, this is increasing. 5 over 2 is greater than 1. That's increasing. 1.5 is increasing. 1, well, we don't have an exponential function that is 1, as a base 1. And here we have a decreasing function, since 3/4 is between 1 and 0. Which exponential function represents the graph shown? So here we have an increasing exponential function. The graph goes from quadrant 2 to quadrant 1, as with any exponential function. That is the only in behavior for exponential functions, from quadrant 2 to quadrant 1. We have a y-intercept of 4. So in this case, when we're looking at y equals a b to the power of x, a must be 4. So we have two equations here where a is 4, c and d. Regardless, a shows us a decreasing function, and we're looking for an increasing function. Here c, 1/4 is between 1 and 0. It's not greater than 1, so that will give us a decreasing function. And we are looking for an increasing function, so our answer will be D. The population of a strain of bacteria growing in a petri dish is modeled by the function here, where P of t represents the number of bacteria and t represents the time in hours after the initial count. How much time will it take for the number of bacteria to reach 12,000? So we're looking for time. We have 12,000 is equal to 3,000, which is our initial amount. Doubles every 4 hours. And so, when we're solving for time, the first thing we must do is get the power by itself. So we will have 12,000 over 3,000 is equal to 2 to the power of t over 4. So here we have 4 equals 2 to the power of t over 4. Now there is two ways to attempt this. We could have method 1, which is what we learned in Chapter 6. We're going to change 4 to a base of 2, and this is the most convenient way. That'll be 2 to the power of 2 would equal 2 to the power of t over 4. And therefore, because the bases are the same, we can equate the exponents. 2 will equal t over 4, and of course 8 would equal t. That is one method from Chapter 6. And then in Chapter 7, which you would know about Chapter 7 now because you're at the final, there is another way of doing it. When you solve, you could take the log of both sides. I'll just change color here. So the second method is that you could do log 4 equals log 2 to the power of t over 4. And then the laws of logs, the power law tells us that this should come in front. So we have log 4 equals t over 4 times log 2. And so since we're solving for t, we'll divide both sides by log 2. We have log 4 over log 2, and we can use our calculator to calculate this since it's log of base 10, it's the common log, t over 4. And when we use our calculator to calculate this, we get 2 equals t over 4. And now we're at the same step as this one right here. So once again, this method will always work when we're solving for t. This will only work when these two numbers can be written as the same base. Here we have solve for x. We have two exponential equations equal to each other. it's very convenient here to use the same base method. So we have 2 to the 3x plus 1 equals 2 to the power of 2, all to the power of 2x subtract 1. Now here you have to be very, very careful, because a common mistake here is only multiplying this exponent by the 2x. When you have to use the distributive property here, that 2 should be multiplied to 2x and the negative 1. So we have 2 to the 3x plus 1 is equal to 2 to the 4x subtract 2. And now since the bases are the same, we can equate the exponents. We have 3x plus 1 is equal to 4x subtract 2. So 3x subtract 4x is equal to negative 2 subtract 1. That gives us negative x equals negative 3. So x will equal 3. Which is true about the table given. So we're looking at a table. We can find out what the b is, what the rate is, and that's 20 divided by 10 is 2. 40 divided by 20 is 2. 80 divided by 40 is 2, and 160 divided by 80 is 2. So it does double. We are doubling, not triplet. And our initial value is at 10. Our initial value is where x or the time will be 0. It's not necessarily the first thing in the table. It's when x is 0. So we have a. Just a little side note here, if we're going to create the equation for the function modeled by this table, we do have b equals 2, and we do have a equals 10. Yet we have another one, since it doubles every 3 years, we have a c value, or an h value, because you could look at the equation as y equals a times b to the power of x over c. And this equation would give us y equals 10 2 to the power of x over 3, since it doubles every 3 years. The increment here is 3. The function that models the K of carbon-14 is right here, which is the half-life formula. That's a half-life. What happens in the half-life, it starts at, in this case it'll start at 100, and then after 5,730 years, it will be half its mass, or half its amount, which in this case will be 50. So it says, which statement is true? The amount of carbon doubles? No, that's not right. It's a half-life. There are 50 grams of carbon initially present. No, there are 100 grams initially present. 14 grams will be present after 15 years. I'm not quite sure to answer that. I'm pretty sure it will not be, since after 5,730 years it will be 50 grams, which is the next one. 50 grams of carbon will be present after the first half-life, and of course that's true. 50 grams being half of its initial, right? Half the initial amount. So here we have algebraically solve for x. This is a, with previous public exams, it is a common constructed response item. Recall that when we're dealing with radicals, it means fractional exponents. So we have 3 to the power of 1/2 is equal to 3 to the power of 3, which is 27, to the 4x plus 1. And so we're using the distributive property here. That is going to be 3 times all of 4x plus 1, so 3 times 4x and 3 times the positive 1. This will give us 3 to the 1/2 will equal 3 to the 12x plus 3. And so since the bases are the same now, we can equate the exponents. 1/2 will equal 12x plus 3. So we solve for x. 1/2 subtract 3 would equal 12x. This will give us negative 5 over 2 would equal 12x. And so negative 5 over 2 times 1/12 will equal x, or divide negative 5 over 2 by 12, and this will give us negative 5 over 24 will equal x. So once again, it is a common constructed response item to algebraically solve for x. We have to watch here for the radical, which turns into rational exponents, fractional exponents. Nora is about to invest $5,000 into an account that pays 6% interest a year, compounded monthly for the next 3 years. A different financial institution offers 6.5% interest compounded semi-annually for the next 3 years. Write a function that models the growth of Nora's investment for each situation. Should Nora invest her money in this financial institution instead? So I'll say let's go with bank. I'm going to call it Bank A and Bank B. Bank A, her interest is equal to 6%, but it's compounded monthly, so that's 12. So her interest is 0.5%. Her number of compounding periods N. Since this is financial application, we have A equals her principal, 1 plus the interest to the power of compounding periods. And once again, the interest equals the total interest per year divided by the number of compounding periods. And the compounding periods will equal the time, which is 3 years in this case, times 12, because it's 12 times per year, which equals 36 compounding periods. When we calculate this, we get her future value will equal her 5,000 principal, 1 plus 0.005 to the power of 36. That is 0.5 as a percent as a decimal. And this will give us $5,983.40. That's what you'll get after the 3 years. Change colors here. Bank B, I'll call it. Bank B, her interest will be 6.5, where it's semi-annually, that's twice a year, and this will give us 3.25%. And the number of compounding periods, since it's 3 years and it's twice a year, will equal 6 compounding periods. So we have our future value will equal the principal, which is $5,000, 1 plus 0.0325 to the power of 6. This will give us $6,057.74. So I said, which financial institution should Nora invest in? And she should invest in Bank B, since it will give her more money. She will gain more interest in Bank B. So number 28 to 33 on the multiple choice on the public exam will be from Chapter 6, Exponential Functions. The constructed response items will be number 56. You can be sure that it will be a algebraically solve exponential equations, and there will be a word problem, whether it's financial application or half-life or a population growth question. There will be a word problem for exponential functions, and there will be algebraically solved for an exponential equation.